In this video, I'm going to chat about the difference between an axis and a derived median line as it relates to geometric dimensioning and tolerancing. This is according to the ASME, American Society of Mechanical Engineers standard. ISO might do it a little bit differently. So these terms are often thrown about as if they're the same, an axis and a derived median line. For the most part, people just call everything an axis. Now, there are differences between them, and this is important when it comes to inspection to know what you're looking for. If you inspect a derived median line as if it's an axis, you're going to get a different answer. So, first, what is a derived median line? A derived median line is a line made from the center points of all cross sections of a cylindrical feature. So it only applies to cylindrical features like holes or pins. If the part is perfect in form, it's at its MMC, perfect form, the derived median line is perfectly straight. If the part is not perfect, the derived median line will be bent. It will not be straight. So let me show you what that looks like on the board. Say we have the ideal pin up here. The actual part looks like this, right? So to find the derived median line, we're going to look at every opposing 2 points and find the middle of each throughout the whole feature. So let's find the middle of these 2 points. We'll find the middle of these 2 points, and we just keep going through the entire part. Now, if you looked at it from a sectional point of view, say you had a part like this, the middle of this point and this point would be right there, right? So we're just finding all the median or middle points. When we connect them, that's our derived median line, okay? So it's the middle of every cross section of the part. Now, what is usually paired with the derived median line is a straightness tolerance, straightness of a derived median line. So you might have a feature control frame attached to the dimension, which is the only allowed way to put the feature control frame for the derived median line control. This indicates that there's a cylindrical tolerance zone of 10 thousandths in which this line must lie. So you could imagine if your tolerance zone is a cylinder going through the middle of the part, if all of these points lie within that cylinder, the part is good. If part or points are outside of the cylinder, then the part is bad, okay? So this is kind of difficult to check on a surface plate. CMM machines have absolutely no problem with this. If it's RFS, so no MMC or LMC in here, it means it applies regardless of feature size. So this never changes. Now, straightness can be applied at MMC, so you could have a virtual condition and make the part much easier to check, okay? So that's a derived median line. Now let's chat about an axis. So an axis is always perfectly straight. The axis is the center of the actual mating envelope. So what's an actual mating envelope? It's a perfect feature opposite of whatever you're measuring. So the actual mating envelope for a pin is a cylinder that collapses onto the pin until it makes maximum contact, okay? So the axis of that cylinder is the axis of the feature. Let me show you what I mean. So if we put our pin in a cylinder, so a ring gauge or a hole or something that collapses on it, until the gauge stops moving, right? We've made maximum contact. It's touched enough points to where that pin doesn't wiggle around. That establishes the actual mating envelope. Whatever the axis of this cylinder is also the axis of the part. okay? So it's a little counterintuitive how, you know, you're comparing the axis of this and saying it is the axis of that, but as far as mating, which is what we're concerned with the ASME standard, you want to know if this part will fit into a similar feature. So the axis of this, say we start out here, right? Whatever the center of this cylinder is also the axis of this part. Now, the derived median line, like we talked about before, is not straight. The derived median line is more or less like this, right? It's a curved thing. Now, they're similar concepts, but different. Now, this is an unrelated actual mating envelope. It's all it could be with this kind of feature. If you have a feature or a part with more than one feature, you could have a related actual mating envelope, which just means that the AME is constrained to datums. So it'll still have an axis, but it's just a difference in terminology. So that's essentially the difference between an axis, always straight, and a derived median line, which is only straight if the part is perfect. Derived median lines are used for straightness tolerances, basically exclusively. An axis can be used with orientation and position tolerances, okay? So that's it for this video. Just a quick word on the difference between an axis and a derived median line.